every function in JavaScript is first class. That's short for first class citizen. But what does that mean? Thanks for asking, Oli. Also, did you guys see this?
Hi, I'm Sina. I'm a senior engineering manager at Frame.io.
That was cool, right? Now you know what I do for a living. Some of you even messaged me and said that was awesome. Thank you. Anyway, first class functions, right? There's a short answer and there's a long answer. And I'm gonna give you both of those because Oli asked. And as we all know, there's a little Oli in all of us. So a question for Oli is a question for many. So today I'm gonna tell you what it means when we say functions are first class. Plus I will show you 7 benefits of first-class functions that I could come up with. They open new paradigms for us, including functional programming, and that makes coding faster, cleaner, and declarative. I will show you each of these 7 characteristics, and I will give you examples of each of them. And in typical color code fashion, I will tell you why it matters, what it means for you practically every day when you're writing code, and how you can apply them to write better code. This is episode 17 of 20 things JavaScript developers should know, but probably don't. First class functions. Buongiorno tutti. So first-class citizens as a term outside of programming refers to those who have all the rights and privileges and responsibilities as anyone else. Actually, it's kind of fucked up that we even have the concept of second-class citizens because we're all the same, man. Yeah, right, okay. Sure. Regardless, in JavaScript, functions are first-class citizens, and that's definitely not the case in every programming language. Actually, I don't believe they are first-class in Java, so you don't even have to go that far to find one. And that just means that in JavaScript, you can do everything with functions that you can do with any other data type. That's the short answer, that they're capable of doing anything that any other data type can do. A slightly longer explanation, as I mentioned in the intro, I will break down into 7 things. And I'd rather show you than to tell you, so let's write some code, yo. To the browser. All right, number 1, you can assign them to variables. So I can say things like const a equals some function expression, something like this. Okay, why is that good? Well, why is assigning anything to variables good? Most obviously, it's reusability. Variables hold values for us for later use, so we can use them multiple times. Reusability. It's a fundamentally good engineering practice because it removes duplication, so you don't have to write the same function twice. Let's write a function that logs the current time. So this would be console.log, whoops, get out of here. Let's do const now equals new date. From here, I'm gonna do, let's do one of these, now.get hours, is that right? And then colon, bam, get minuti. And let's also rename this to what time is it? If I assign it to a variable like this, I can call it on its own. What time is it? 1744, okay. Or I can call it from a timeout. Let's do set timeout. Set timeout. Let's see what time it is after 1 second. There, so it's just gonna do that. Or I can do a set interval, for example. All right, it will do this on every 1 second, or whatever the I want. So I can reuse this. Now, what other benefits do variables give us? Readability. Assigning variables or functions to a variable with a descriptive name helps me understand what that function does. So let's go back to the browser. Let's do a set timeout. This time I'm not gonna have a named function or a variable. I'm just gonna do an inline function after 1 second. Let's say this does, I don't know, thing 1, and then it does thing 2, thing 3, and then it alerts. I don't know what alert's gonna do inside this tool I'm using. Things are done, yo. Actually, it doesn't do anything. How about console log? After 1 second, it does that. So this function right here does a bunch of things. And I don't know what those are. If I have to read the code in order to understand what it is, or what it does rather. Instead, if I copy pasta this guy and say const do things, which is actually not a good name whatsoever. Do things. If this was better named, it would be a descriptive way for me to refer to what happens after my 1 second in my set timeout. So imagine this do things was a better name. That's what having a variable allows us to do. Number 2, functions can be passed as arguments to other functions. This is a big one. A classic case of this is callbacks, right? So let's go back straight to my tool. Function fun1 receives a callback, and after a bunch of things happens, it calls my callback. And then we call fun1 and we pass it fun2. Right now fun2 doesn't exist here, so it's gonna say fun2 is not defined. But why is this good? Well, I'm glad you asked. Enter name here. Well, the whole reason we can do things in a functional way or declarative, for all you smart babies out there, is because functions can be passed around. Every time we use array.map, you're passing a function into the map function as an argument. React babies know what I'm talking about. So let's write some stuff here. Let's say const array equals 1, 2, 3, 4. Wow, I was off. And then let's do array.map, and we want it to do what? Const elements equals array.map. Again, React babies know what this is. I don't even have to do a function here. I can say li. Listen, my tool's not gonna like this because I'm not inside a browser, so just ignore the errors here. In React, we do this all the freaking time. Well, I can pass a function like this, or I can pass a function that is assigned to a variable, or a named function. The reason why this is good is modularity. This means we can have higher order functions, which can encapsulate common behavior, which means our code can be separated into different functions, into different modules, aka modularity. So if I pull this function into its own thing called, what do I want to call this? Create element, right? My God. Ugh. Function create element. Yikes. There we go. And I'm gonna fix that. So in order for me to get rid of this error, I'm just gonna return item. But imagine if I created an element and returned the item, right? Now there are separate pieces that are modular, which means reusability. Modularity promotes reusability. Both the higher order function map and the callback, the create element, can be reused. Excellent pattern. They're not tightly coupled. This saves time and duplication, and you can reuse the same code more than once. Modularity also promotes testability. I can write unit tests for this one little function without having to worry about where it's used and how it's used. And lastly, abstraction. It allows abstracting repetitive kind of steps and functions, making the code base a little bit more concise and maintainable. Let's change this a little bit. I don't like the idea of creating elements that aren't actually elements. Let's say our function was a squared numbers, right? This is a function that takes any number and gives you a squared version of that number. What is squared? Times 2? Is that what it is? Let's say that's true. Squared numbers, I'm gonna do this, right? And then what is elements? Elements. Great. So now squared numbers can be, again, treated separately as a different module, tested, all that good stuff. Tea break. Ah, yes. Number 3, functions can be returned from other functions. This one's probably the hardest to understand why it's good and why do I need to return functions. First one is returning functions from other functions means we can create factories. I've covered function factories over here, so check it out. This means we can create customized versions of functions based on input. I'll show you what I mean. For example, say I have a function that takes language and name as 2 parameters, and it greets you in that language. We're only gonna support 2 languages because we're lazy, but let's get there. So function, say hello. What do we say? Language and name. I like writing code with you guys. It makes me feel connected to you. Language. We're gonna do this the most naive way possible. This is not about the implementation of the function. This is about the benefits that I'm about to show you. Console log. Hello, name, else if language is Italiano, ciao. Ciao, ciao, ciao. Okay, let's do say hello. English wins by default, but anyway. En. And then who do I want? Oli. It says hello, Oli. Oli. Say hello. What about in Italian? It says ciao, Oli. Okay. Well, this is interesting. I can write it like this, where I pass the language every time, or we can convert this to a factory function or the factory pattern. And I can return a function instead of doing the whole logic inside my function. Let's see what that looks like. So I'm gonna change this to, well, say hello is fine. And then I'm gonna say return a function. Okay, let's do that. Go down. The function actually takes language, but then the secondary function takes name. You will see the benefits in a second. Bear with me for a minute, and everything else the same. I believe that that's gonna be fine. So now say hello returns a function, and it only takes language. So what does this do now? It doesn't say hello anymore. We should rename this to say greeter or greet creator, something like that. Greeter factory, naming is hard. Const English greeting equals that. And then we have Italian greeting, IT. All right, well, so far it's just more code, right? I don't understand why this is better. Here's why this is better. I basically created two different versions of the greeter function, one for each language. By the way, I get it, this is not the most efficient way to write this, but again, this is not about the implementation of the function. It can definitely be improved upon, but I'm making a point about function factories. So calm down. So we just encapsulated the logic, meaning I can now call English greeting. I can say English greeting. I want to blame it on my keyboard, but it's not. Ciao, Oli. I can do ciao, Sina. Hello, Francisco, right? So I can now use the English version of it, or I can use the Italian version of it. Give me 3 Italian names. Maria. Mario. And then Maria, why not? And then give me a third. Danilo. So again, we had this parameter that we had to pass in every single time. Now we don't have to do that anymore because we created customized versions of our function, because now our function is returning its own like smaller mini function from inside of it. This also means that we encapsulated the logic, meaning my API, the API of the ultimate function that I have to call, is now smaller. It's now boils down to its essentials. The only thing that is different from between these three is the name. So I made the API of my function be slimmer and smaller and cleaner. I love that. Plain code base. All right, let's move on to number 4, is currying. And it's very similar to what we just discussed. Functions can be curried for partial execution. Kind of an advanced technique in the functional programming world, but it's not that difficult from what we just looked at. This is also a byproduct of the fact that functions can be returned from other functions. What this really means, again, we can create specialized versions of functions with predefined arguments. Very similar to function factories. So let's see a different example. Let's say we have a function that is meant to show us the total price of a thing in a currency of our choice. Maybe it's 2 parameters, kind of similar to before. Print total. And the total, what does it say? Amount, nope. Amount and sign, right? Say hello. And it returns. I've been doing console log, but I should probably do returns. It's a little more professional, wouldn't you say? And then I want to say amount, or the sign goes in front of it, right? Yeah, we should do sign to the rugs topography. What if we have something like this, right? The issue is, what is the issue? Well, let's try to reuse this function a bunch of times and see what happens. Should I zoom in? I'll zoom in. I got you, brothers and sisters. Print total. What do I want to do? I want to say, let's say 46 is the amount. $sign is the dollar. 46, 2, 46 and 2, just ahead of me. 10,000 days in the fire. 25 or 6, 4. So, okay, well, that's fine. This is all US dollars. Let's move to Europe. European sign, how do I do this? My notes say Shift Option 2. Okay. Euro. 8 for 8 days a week. What else? 1,000 times 1,000 years. Well, that's also a British artist, but I'm using euros. I should be using pound for the British artists, right? What happened, guys? Let's come up with one more European, ideally 19, I guess. 19th nervous breakdown. Are you wondering what I'm talking about? These are all songs. Okay, so these are all British, but I'm using the euro sign. Don't worry about it. Should we change it? Okay, let's change it. Option 3. Here we go. Pound. 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 Big house. You see something wrong with this? Because I do. I'm passing the sign in every single time. Very similar to the previous example. Repetition. Bad. What if we curry it? Okay, well, let's try that. Sina. Let's return a function instead that takes the amount, right? So we would want to pass in the sign first and then eventually the amount. So now I can create const total, US dollar, USD total or US total equals print total with the US dollar. And now I can refactor these to, I no longer need to do any of that. That. Why am I getting undefined? Because I'm passing that. To print total, what's wrong? Okay, sign is going to be that. Bam! And then I can create a UK version of this. UK total. And I'm gonna pass in this sign. Refactoring in real time, baby. And 1,000 years. And then I can say UK total, right? So I created specialized versions of my function, a US version and a UK version. And that's only possible because I was able to curry this function into, instead of having it accept multiple parameters, now it only accepts one parameter. And we sort of chained those. So you see a lot of currying examples on the web, and they don't really make sense because they take 3 or more parameters and break it into smaller pieces. And the way they use them is like this. I never understood that. I never understood like why people would want to do stuff like this, like parentheses after parentheses. But so this way of thinking about currying made more sense to me. So I wanted to explain it to all of you beautiful babies. So again, this allows us to use a part of our function, but not all of it. Moving on to number 5, closures. We get to have closures and they rock. I dedicated a whole video, a whole episode to closures, I believe episode 8. You can find it here. So I'm not gonna repeat all of that, but I will show you an example. And for this one, we need the DOM. So my tool isn't gonna work. So I will show you in my trusty animation board. So say I had 3 buttons, and when I click each of them, the size of the body text changes. So we want this logic to apply to all of the 3 buttons, except that for each button, it's a different size. I can put it inside a closure. So a different version of this function gets created for each of the buttons here and retain the size that was passed during the creation of the function. There is so much more to learn about closures, so check out the video I mentioned because I go into some of the nuances there. But that's closures for you. Number 6, they can be stored inside data structures. Functions can be stored inside arrays, inside objects. So I can say const my functions, and I can put them literally inside a greet, or what did I have? Another function. I have even like inline functions. All of these are going to be inside my array, and that is absolutely legal in JavaScript. Why do we care? Dynamic data manipulation. So that's a big term, but basically what it means is storing functions in an array means we can manipulate our code's behavior so that it is dynamic at runtime. For example, an array of basic math operations, right? Like add and subtract, means that we can call these functions based on a user input. I'm just gonna copy paste this because I already have it in my notes. So let's say I have the add and subtract function. So these just take 2 parameters and plus or minus. And I can store my functions inside an operations array. That operations can be, this number 0, this can come from the user. The user we can have buttons, we can have an input where a user can say, I want to perform an operation that is the first or the second. And that means the execution of our code now can be dynamic because I can go into the array and pull whichever function I want and execute that, as opposed to sort of a static script where it just goes through functions and executes them. The other benefit of this is code organization. So if we put this inside an object, let me convert this into an object and do that. Clean this up a bit. Add, right? Instead of storing them in an array, I'll do an plus B, and then subtract will be kind of the same thing except minus minus. There. This really does improve the code structure to make it easier to manage. By the way, this is why we can have object methods. Do you notice this? These are methods inside an object. So if functions couldn't be inside data structures, other data structures, then we couldn't have object methods. Isn't that nice? Thank you, object methods. And lastly, again, for the React babies out there, when you use a hook like useState and it returns an array of state and set state. Well, what do you think set state is? It's a function, and we can do this because we can store functions inside an array. So you just get an array back from the hook, and that's awesome. And lastly, number 7, functions can be anonymous. They can be defined without a name. Isn't that f***ing insane? And still treated as first-class citizens. Now, why is that useful? 1, less code. This is the opposite side of what I was talking about with regards to named functions and assigning functions to variables. This is useful. Anonymous functions like this are useful for short-lived kind of one-off functions that you don't need to reuse, and it's not necessary to assign a name to them. Especially with error functions, this is particularly nice. This is really concise code. Second is inline callbacks. Callbacks are also, we talked about them a little bit. They're really common in asynchronous programming. I've also touched on that a little bit. Maybe I put a link over here. And event handling, right? Again, if you don't want the function to be called from multiple places, you can just inline it anonymously, and that's kind of cool. And lastly, anonymous functions can be immediately invoked, aka iffy. Not a huge fan, but it's worth knowing that something like this used to be a lot more common in JavaScript. We don't write these as much anymore, at least I haven't run into them as much, but that is a thing. So to recap, functions are first-class citizens in JavaScript, but not in every programming language. But in JavaScript, they are, which means we can do with them everything that we can do with any other data type. And that in practice means 1, we can assign them to variables. 2, you can pass them into functions as parameters. 3, we can return them from other functions. 4, we can curry them. 5, we can create closures. 6, we can store them in data structures like arrays and objects. And 7, we can create them anonymously and invoke them immediately. I probably didn't have to say the numbers, did I? It's already there. Wow, redundant. And hopefully by now you can tell that there's a clear pattern of reusability and flexibility here. So much of the benefits that we get from the first-class nature of functions is about writing cleaner, maintainable code, and in most cases, less code. Isn't that funny that we learn all these theories and techniques and things just so we can write less code? Life is funny like that. And with that, now you know what it means when an asshole says, functions are first class, man, and pretends he's better than you. Now you know what that means. This was episode 17, and yes, these are new glasses. Thank you for noticing. The next episode is one of my faves. I finally did it. All of you asked me to do an episode on the almighty event loop, and I'm finally gonna dedicate episode 18 to that. It's gonna be awesome. It's a foundational concept in how JavaScript even works, so tune in for that. And until then, me love you very good. Ciao, ciao, muta.